Yes, today we shall consider the problem of constructing X bar and S chart, right? See, in this problem, X bar values and S values are given using the samples of size 5 that they have been computed, right? Already for 13 lots, they have taken samples of 5 each, and for each of the sample mean X bar and the sample standard deviation S has been calculated and given for you. Otherwise, you should have calculated it. Okay. Now, for 13 lots, the data is given. Now, let us consider the process of constructing the chart. See, for the answer, you should extract the table value for, see, for n is equal to 5, the value of A3 is 1.427 and the value of B3 is 0. I have written here, and the value of B4 is 2.089. So this we are taking from the control chart, the factors for constructing variable control charts, and from this table I am taking the values corresponding to n is equal to 5. Okay, fine. So we have computed this. Then we need X bar bar. See, I have calculated the total of the mean 150 plus 145 plus 142 up to 153 gives me 2000 divided by 13. Why 13? 13 lots are there. You have added 13 observations. So the answer is 153.85. Similarly, you should compute S bar, for which I should add all the S values. 21, 528, 33, 34, 39, 48. Okay, you just add all these values. Okay, correct. So 48 divided by 13, you divided 48 divided by 13 is 3.69. After doing this, let us compute X bar chart, the upper control limit for X bar chart. It is X bar 153.85 plus A3 1.427 into S bar. Let us compute this value, and for LCL it is X bar minus 1.427 into 3.69. Okay, and the control limit for X bar chart is X bar value itself, the mean of means, 153.85. Okay, the control limit for S chart is 3.69, and here it is 0 into 3.69, which is 0. And what is B4? We have extracted it from the table as 2.089 into S bar. So let us compute all these values. 2.089 into 3.69 is 7.7. I think you can round it to one decimal place, because only those values can be accommodated in the table. In the graph, I'll tell you how. Here 153.85 minus 1.427 into 3.69. So the lower control limit is for X bar chart is 148.6. Okay, then 153.85 plus 1.427 into 3.69, it is 159.1. Fine. Okay, so we have computed all the control limits. Now let us come to the chart. Okay, now see, here I am constructing the X chart. See, for S chart, the maximum value is 7.7, the upper control limit. Also, in the given question, the S values, the least value is 1 and the highest value is 7. So I should select a range in such a way that maximum of 7 values are accommodated. So I've taken the scale as 1 unit on x-axis, 1, 2, 3, 4, 5, 6, 7. I go up to 8. So here I am going to plot the S values, and on x-axis I have taken the lot number. Okay, The lot number is from 1 to 14. I have written the scale as x-axis 1 centimeter equal to 1 lot or 1 unit, and y-axis 1 centimeter equal to 1 unit. I am going to plot the values. See what values are to be plotted. First of all, let us draw the control lines. See, this is the lower control limit, which is 0 for S chart. Okay, the upper control limit is 7.7. Since I have taken whole numbers here, I go up to 1 decimal place. Have this clue in your mind. If you have up to 1 decimal place here, round up to 2 decimal places. Okay, this is the right clue. So 7.7. 7 is here. 0.7 is 7.5, 7.6, 7.7. Okay, so this is your upper control limit, and you know that the upper control limit and lower control limit should be represented as split lines. Okay, so this is my upper control limit for S chart, which is 7.7. Lower control limit is 0. Control limit is 3.7, 3.5, 3.6, 3.7. Control limit is 3.7. Okay, let us plot the values of S. See, S is given in the problem. For the first lot, what is S? 3. For the second, it is 4. For the first, it is 3. Okay, for the second, it is 4. For third, it is 5. For fourth, it is 2. For fifth, it is for fifth, it is 7. For sixth, it is 2. Sixth, 2. Seventh, it is 2. Okay, for seventh, it is 2. For eighth, it is 3. For eighth, it is 3. For ninth, it is 5. S value. S values are plotted. Okay, and 10th, it is 1. For 11th, it is 3. For 12th lot, it is 6. For 13th, it is 5. Fine. See, all values are falling within the control limit. It increases and then it goes like this. The trend is like this anyway. All values are falling within the control limits. So you write, since all values in S chart fall within the control limits. All values are points. All points fall within the control limits. What is in control? The process variability is in control. Okay, the process variability is in control. Fine. Okay, now let us go to xbar chart. See, xbar values. We want to verify whether the process average is in control. A very important thing. I have taken lot number on x-axis. X-bar value should be plotted on y-axis. Okay, let me see the range. The least value here is 142 and the highest value is 165. And seeing the limits also, it is somehow below 159 is the upper limit. So up to 165, 166, the values are to be accommodated. My space is very less, so I decided I can go for 2 units, right? I can see this graph. I start with 142. The lower part I have hidden, that is the meaning. Okay, if I do like this, I have hidden that part because only this part is required. 142, 144, 146, 148, 150, 152. See, least value is 142. That's why I have taken 2 units. 154, 156, 158, 160, 162, 164, 166. Listen, now you should carefully understand. See, the difference here is 2 units, and this 2 unit difference is divided into 10 parts. So each small line should be counted as 0.2. That is what you have to understand. Now let us plot the upper limit. Upper control limit is 159.1. See, 159 is here, and the next line, small line, will be counted as 159.2. So 159.1, you round it as 159. You have no other go. 159.1 should be plotted between 159 and between the 159 and 159.2. Okay. So better have it as 159. Write it as 159.1. Okay. And the lower control limit is 148.6. See, 148, 148.2, 148.4, 148.6. Okay. 0.2, 0.4. This is 148.6. 0.2, 0.4 here. Okay. Okay. What is this 148.6? This is lower control limit, 148.6. Okay. Control limit is, you have to round it to 1 decimal place, right? 153.9. Here you have 153. See, this thick line is 153, 0.2, 0.4, 153.2, 153.4, 153.6, 153.8. Then comes 154. Okay. So this line. So control limit is 153.9. Okay. Now let us plot the values. The first, mean of the first lot is 150. The second lot, it is 145. For third, it is 142. Fourth, it is 148. For fifth, it is 155. And sixth, it is 160. Seventh, it is 159. For eighth, it is 165. For ninth, it is 151. For 10th, it is 153. For 11th, it is 157. For 12th, it is 162. For 13th, it is 153. Fine. So you should have drawn it as with split lines. Lower control limit, have it as split lines. Okay, don't draw thick lines. And also for the upper control limit, have it as split lines, don't forget. Okay, right. See, some 3 points fall below the lower control limit, 3 points fall above the upper control limit. The process average is not at all in control. Let us write 3 points fall below LCL and 3 points fall above UCL, upper control limit, in xbar chart. So the process average is not in control. The process has to be corrected. Okay, the process average is not in control. This is the conclusion, right? Thank you.